Good morning, class, and you are all welcome to this lecture. Last week we talked about probability and on statistical science for engineering and physical sciences. We are studying study section 4, unit 1, which is random variable. What are the objectives of this study unit? The objective of this unit is to provide students with a clear understanding of the random variables and their roles in probability and statistics. By the end of this unit, students will be able to 1. Understand the definitions and differences between discrete and continuous random variable. Learn how to describe a discrete random variable using its probability distribution. Compute and interpret the mean, that is, the expected value of a discrete random variable, as a measure of central tendency in probability distribution. Calculate the variance and standard deviation of a discrete random variable to measure variability, and also apply this concept to solve real-world problems in sciences, engineering, and business contexts where outcomes are uncertain. Learning outcomes for study section 4, unit 1. By the end of this session, students will be able to 1. Define a random variable and distinguish between discrete and continuous random variable. 2. Describe the probability distribution of a discrete random variable and explain its properties. 3. Is to compute the mean, that is the expected value of a discrete random variable using the probability distribution. 4. Interpret the mean as a long-run average outcome in repeated trials of an experiment. Calculate the variance and standard deviation of a discrete random variable and explain the significance of variance and standard deviation as a measure of spread in probability distribution. Introduction. In probability and statistics, many real-life situations involve outcomes that occur by chances. To analyze such situations, mathematically we use the concept of random variable. So what is a random variable? Random variables are fundamental concepts in probability theory and statistics. What are they used for? They are used to describe and analyze the uncertain outcomes of a random event. The distribution of a random variable provides information about the probabilities associated with each possible value it can take. It also describes how the values are spread, that is the dispersion, spread out, and help us to understand the behavior of a random variable. Also, understanding the mean, that is the expected value, and variance of a random variable is essential for summarizing its behavior. The mean represents the long-term average outcome, while the variance measures the degree of spread or variability around the mean. Common distribution used in model. Common distribution that we can use to model random variables include binomial distribution, Poisson distribution, uniform distribution, normal or Gaussian distribution, exponential distribution, and many others. Each distribution has its own characteristics and mathematical properties, making it suitable for different types of random phenomena. Now, what is a random variable? A random variable. A random variable is a function that assign numerical values to each outcome, which is defined by the sample space. Let me go back again. What is a random variable? When we are talking, what is a random variable? We say a random variable is any function that assign numerical values to each outcome defined by the sample space. Last week we said sample space is set of all possible outcomes in a random experiment, and we say it is denoted by capital S, omega, or U. So now a random variable is any function that assign a numerical value to each outcome which is defined by the sample space. That is a function x that is assigned to every element that is contained in the sample space one and only one real value. of x into bracket c equals to x. For example, consider x to be number of heads obtained in 3 tosses of coin. Like if our random experiment is to toss coin, 3 coins, 3 tosses of coin, is to toss coins, 3 coins. We toss it. What are the sample space that we can get from that random experiment? Is either we obtain 3 heads, there is probability that 3 heads, we obtain 3 heads, we obtain 2 heads and 1 tail, we obtain head, tail, head, we obtain head, tail, tail, we obtain also tail, head, head, tail, head, tail, head, tail, 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 head, or tail, tail, tail. That is 2 raised to power 3, which will give us 8 sample space. So the variable is random. If the value that will occur in a given instance cannot be predicted, that is, we cannot predict the value that after tossing our coins, we cannot predict the value that will occur in a given instances. We can make list of entries, outcomes associated with x. Let us say numerical value of x as an event and the comparative of the event. If our x is 0, after tosses of the 3 coins, our x is 0. That means we don't have any head. Or after tossing, we have 3 tail, no head. That means our x is 0. The comparative of the event is all our tosses present tail. When our x is 1, that means we have 1 head. From this sample space, we have 1 head, which falls under the category of either head, tail, tail, is only 1 head that is present, tail, head, tail, tail, head, tail is only 1 head that is present, or tail, tail, head is only 1 head that is present. Let's say that is when our x equals to 1. That means our x is the number of heads that we have in our sample space. When our x is 2, that is those ones that we have events whereby we have just 2 heads, which are head, head, tail, head, tail, head, and tail, head, head. And the last one, which after 3 tosses of the coins, we obtain 3 heads. That is 1, which is 1 over 8. So we have head, head, head. The possible values of a random variable can be directly derived from the distribution of the random variable without listing the sample size. Let me repeat myself again. The possible value of a random variable can be directly derived from the distribution of the random variable without listing the sample size, sample space. Random variables are classified into 2 main types, which are, we have the discrete random variables and the continuous random variable. When we say discrete random variable, what is a discrete random variable? A discrete random variable is a random variable that can take on only a finite value of values, or whose choice of values is countable. Any random variable that is countable, that its values or the choice of values is countable, is called a discrete random variable. E.g., the number of cars sold in a day, we can count it. We can count the choice of value. Another one is the number of heads in 10 coin tosses. Like the example we did for tossing 3 coins is a discrete random variable, because from there we can count those that have 0 heads, no heads, which is 1 over 8. We can count the ones with 1 head, 3 over 8, the one with 2 heads, and like that, and 3 heads. So a discrete random variable is a random variable that can take on only a finite number of values, or whose value of choice is countable. E.g., number of cows sold in a day, the number of heads in 10 coin tosses. What are the properties of a discrete random variable? The properties of a discrete random variables are: 1. Discrete random variables have countable values. That means they have countable values, e.g. the number of heads in 3 coin tosses can only be either 0, 1, 2 or 3. 0, no heads; 1 head, 2 heads or 3 heads. Its probability is between 0 and 1. The probability of a discrete random variable is always between 0 and 1. That is, for each possible value of xi, the probability p of x equals to xi must satisfy 0 is less than or equals to p of xi equals to xi is less than or equals to 1. That is, its probability is always between 0 and 1. The third one, the sum of probability is 1. That means when we sum all the probability of a discrete random variable together, the total is always 1. The summation is always 1. All the probabilities of discrete random variable, the sum must be equal to 1. That is, the total probability over all possible values must be equals to 1. That is, our summation of p of xi, x equals to xi, must be equals to 1. Number 4, property number 4, the list or table of xi values and their probabilities. P of x equals to xi forms the probability distribution. Let me repeat myself again. The list or the table of our xi, that is when we are talking about tossing of 3 coins, we say when no 0, when our x equals to 0, we have tail, tail, tail. When our x equals to 1, we have just one head, where one head occur. When our x equals to 2, we have where we have 2 heads. And when our x equals to 3, we have where we have 3 heads. So this table or the list of xi values and their probabilities forms the probability distribution. Then the mean or expected value is given as e of x equals to mu. E of x is the same thing as mu, which is equals to summation of xi, p of x equals to xi. That means it's the summation of xi values and their probability times the probability. Summation of xi times the probabilities, that is p of x equals to xi. Also, the variance, which measure the spread of the distribution, is given as sigma square equals to summation of xi minus mu square p of x equals to xi. The last but not the least is discrete random variables are usually represented with probability mass function, which is abbreviated as PMF. Discrete random variables are usually represented with probability mass function known as PMF, often shown as vertical bars for each of the xi. Example: calculate the values of y in the following probability distribution table. Assuming we toss a coin, or let me say assuming we toss 2 coins. Now from here our x is 0, maybe no heads or no tail, 1 head, 2 head and 3 heads. No head, 1/4, 1 is missing, 2 heads, 1/8 and 3 heads is 1/2. From here we say our summation, which is our mu, is summation x ranges from 0 to 3. F of x equals f0 plus f1 plus f2 plus f3. Summation of x equals to 0 to 3. F of x equals to 1/4 plus y, which is missing. That is, the probability of f of 1 is missing. We sum everything together, plus 1/8 plus 1/2. Since f of x is the probability mass function, summation x ranges from 0 to 3, f of x equals to 1. Therefore, 1/4 plus 1y plus 1/8 plus 1/2 all must be equals to 1, because from the properties we said the sum of all probabilities must be equals to 1. From the properties of a discrete random variable, we say all the sum of probability must be equals to 1. So from here now, our y will now be equals to 1 minus 1/4 plus 1/8 plus 1/2. When you sum all together, our y will now be equals to 1 minus 7/8, which is equals to 1/8. Our y is 1/8. Our y is 1/8. When we sum all these things together, that is, since we've known our y, if you sum 1/8 plus 1/4 plus 1/8 plus 1/2, it must be equals to 1. Then the mean of a discrete random variable. The mean of a discrete random variable. Let x be a random variable on a sample space S with infinite image set x of alpha equals x1, x2 up to xn, and our f of xi for our high ranges from 1 to n, the probability mass function mathematical expectation is defined by E of x. That is what we use to represent mathematical expectation in statistics. E of x. We use E of x to represent mathematical expectation in statistics. E of x equals to summation I ranges from 1 to n xi f for fi, which is equals to our xi fi is giving us x1 f1 plus x2 f2 x2 f of x2 plus x3 f of x3 up to xn f of xn. The mathematical expectation, which is our E of x, is denoted by mu x or mu. It is called expected value or mean of x, or mathematical expectation, which is our mathematical expectation is E of x. We can call it E of x, and is denoted by mu. It is denoted by mu. It is called expected value, or we can also call it mean. Then variance of a discrete random variable. Variance of a discrete random variable. If x is a random variable, variance of x, either discrete or continuous, is denoted by VAR into bracket x. Either, listen to me again, if x is a random variable which is either discrete or continuous, we said we have two types of random variable, discrete or continuous. The variance of x, either for discrete or continuous, is denoted by VAR of x. Just shorten the first three letters that begin variance, VAR, then bracket x, is defined as expectation of x minus mu all square. E of x minus mu all square, where our mu is equals to E of x, because we've said our mean is, our expectation of is equals to E of x, or expected mean, or we can also call it mu. So our mu is always E of x. Now our variance of x will now be E of x minus E into bracket x minus mu all square, which is equals to summation of x minus mu square f of xi. Note, our f of xi is a probability mass function. Our f of xi is a probability mass function. So our variance of x, if we expand this, our variance of x will now be E of x minus mu square, which is equals to, if you expand your variance of x, E times x, since it is square, the square is covering the bracket of x minus mu, so it will be E of x squared, then minus any expectation of any mu is equals to mu. Expectation of mu is equals to mu. expectation of any mean is equal to mean. So E of x squared minus mu squared. E of x squared minus mu squared, where our mu is equals to E of x, which is equals to summation xi f of xi for a discrete random variable. Example: a random variable x with assigned probability is defined as capital X, which is equals to 2, 1 and 3, with their probability for 2 is 1 over 6, for 1 is 1 over 6, and for 3 is 2 over 3. Now we form a distribution table. Our values is 2, 1 and 3, and our f of x, which are their probability, is 1 over 6, 1 over 6 and 2 all over 3. The expectation value of x, E of x, we say its summation I ranges from 1 to n, xi f of xi, that means it's the sum of all our xi times f of xi. E of x is the summation of all our fi times x of fi, so which is x1 f of x1 plus x2 f of x2 plus x3 f of x3 up to xn f of xn. It depends on the number of x and f of xi that we have. Now from this example, we have 3 xi and 3 f of xi. So from here, our E of x equals to summation I ranges from 1 to 3, because we are having 3 xi f of xi. So f1 xi summation I ranges from 1 to 3 xi fi xi f of fi, which is equals to x1, that is our 2, f of x1, which is 1 over 6, plus x2, which is 1, times 1 over 6, plus x3, which is 3 times 2 over 3. So therefore our E of x equals to, our x1 is 2 times 1 over 6, plus our x2 is 1 times 1 over 6, plus our x3 is 3 times 2 over 3. E of x, if you multiply this will be 2 times 1 over 6, which is 2 over 6, plus 1 times 1 over 6, which is 1 over 6, plus 3 times 2 over 3, which will give you 6 over 3. So adding this together, it will give us our expectation of x, or mean of x, to be 15 over 6. When you break it down, 15 divided by 3 will give you 5, divided by 6 divided by 3 will give you 2. That will give us 5 over 2, which is 2 whole number 1 over 2. Now we've get the one for mean, then we are calculating for variance too. From the formula for variance, we say our variance is E of x minus mu all square. So let's estimate the one for our x square. Since we are doing for 3 xi and f of xi, we are squaring our xi, then we use it to multiply our fi. So E of x square, they said we are squaring our si, and we use it to multiply our fi. So E of x squared equals to summation I ranges from 1 to 3 x1 xi square fi, which is equals to x1 square f of x1 plus x2 square f of x2 plus x3 square f of x3. So E of x square is equals to 2 square, that is our x1 squared, plus f1 f of x1, which is 1 over 6. The probability of x1 is 1 over 6, plus x2 square. Our x2 is 1 square, plus the probability of x2 is 1 over 6, plus x3 square, which is 3 square, and the probability of f of x3 is 2 over 3. That is the probability of x3 is 2 over 3. Doing this, it will give us 2 square is 4. 4 times 1 over 6, that will give us 4 over 6, plus 1 square is 1. 1 times 1 over 6, that will give us 1 over 6. And 3 square is 9. 9 times 2/3. That will give us 18/3. When you add all this together, it will give you 41/6, which is equals to 6 whole number 5/6. Then to estimate the variance, we said that variance of x either for continuous or for discrete random variable is expectation of x minus mu all squared, which is equals to, when you open this bracket, I explained earlier that it will give us e of x square minus mu square, because expectation of mu is still mu. So and you use your square to open this, it will give you e of x square minus mu square. So now our variance of x, what is our e of x square? The one we estimated, which is 6 whole number 5/6 minus e of x. Our e of x is 2 whole number 1/2 all squared. So when you do this, it will be variance of x will now be, when you convert this, 6 times 6 36 plus 5 41/6 minus 2 times 2 4 plus 1 5/6 square. So this one will be 41/6 minus 5 square is 25 over 2 square is 4. When you do this, find the LCM. What is common with 6 and 4? That will be 12. 6 in 12, 2. 2 times 41. That will give you 82 minus 4 in 12, 3. 3 times 25. That will give you 75, which is equal to 7/12. 7/12. Then variance. The third question says variance 3/5 of x, which is equals to 3/5 square times variance of x. We've estimated our variance of x to be 7/12. So variance 3/5 of x equals to 3/5 square times variance of x. What is our 3/5 square? That will be 9/25. That is 3 square and 5 square. 9/25 times variance of x. From here, we've estimated our variance of x to be 7/12. That will be 9/27 times 7/12, which will give us 21/100, which is 0.321. Now, we've discussed about the discrete random variable. Let's go to continuous random variable. What is a continuous random variable? A continuous random variable is a variable that can take any value within a given range or interval. Discrete are countable values, like the number of cars sold in a day or the number of Coke sold in a year. We can count it. But a continuous random variable is a random variable that can take any value within a given range or interval. The set of possible values is uncountable. It is infinite, meaning it cannot be listed like 1, 2, we cannot count it. Example, height of students. When we measure the height of, maybe in a class of 100 students, when we measure the height of students, it is always within a range or interval. Time taken to run a marathon is also within a range or interval. So, and also temperature in a city is within a range or interval. So a continuous random variable is a variable that can take any value within a given range or interval. Probability are described using probability density function, PDF, not by individual value, where we use probability mass function. In discrete, we use probability mass function, while in continuous, we use probability density function. What are the properties of a continuous random variable? The properties: 1, we said discrete random variable are countable, while an uncountable range of values that can take any real values within a range. It is an uncountable range of values that can take any real value within a range, that is 1.25 seconds. Maybe the time to complete or time taken to run a marathon, 1.251 seconds, within a range. Probability of a single point is 0. Probability of a single point is 0 for any specific value x. P of x equals to xi is 0. Probability of a single point is 0. Probability is only meaningful over an interval. Yes, because a continuous random variable is a variable that can take any value within a given range or interval. So probability is only meaningful over an interval. E.g., probability of A is less than or equals to x is less than or equals to b. So it is within an interval. Probability of x is within an interval of a is either a is less than or equals to x is less than or equals to b. Also, total probability under the PDF curve, that is, total probability is equals to 1. That is, the total area under the PDF curve is 1. And also note that in discrete random variable, you use summation. In discrete random variable, summation x f of x, that is what we use in discrete random variable. In continuous random variable, we integrate, we use integral minus infinity to infinity f of x dx is equals to 1. Please note, under discrete, we use summation x I f of xi. If you could remember, that is what we use to estimate our e of x, and we square our xi times f of xi to estimate our e of x squared. Now, for continuous random variable, we use to estimate the total area under the PDF curve, which is always 1. We use integral minus infinity to plus infinity f of x dx, which is always equals to 1. Also, non-negative probability density. The PDF, that is also another properties of a continuous random variable. Non-negative probability density. The PDF must be satisfied. That is, our f of x is greater than or equals to 0 for all x. Our f of x is greater than or equals to 0 for all x. Another properties, probability over an interval. That is the probability that x lies between. That is the way I explained that, given between x, a is less than or equals to x is less than or equals to b, is given by p of a. Probability of a is less than or equals to x is less than or equals to b is equals to integral, which ranges our interval or our ranges from a to b, f of x dx. The probability between which x lie is a is less than or equals to x is less than or equals to b, which is equals to, for a continuous random variable, integral a, our x ranges from a to b, f of x dx. The mean is computed as e of x, like the way we compute the mean for discrete. But here, instead of using summation, we use integral minus infinity to infinity plus infinity f of x dx, and the variance is also computed as sigma square, which is equals to integral from minus infinity to infinity x minus mu square f of x dx. So the difference between continuous and discrete, when we are estimating our mean and our variance, is for discrete we use summation, and for continuous we use integral. Example, they say let x be a continuous random variable with probability density function. And also note that in discrete random variable we use PMF, which is probability mass function, while in a continuous random variable we use PDF, which is probability density function. Let x be a continuous random variable with probability density function PDF, f of x equals to x over 8 for our x ranges from 0 to 4 and our f of x equals to 0 otherwise. Note that a valued PDF must be satisfied. That is, our integral from minus infinity to plus infinity f of x dx must be equals to 1. That is when our valid PDF is satisfied. No, now minus infinity to plus infinity f of x dx must be equals to 1. So from these examples now, minus infinity to plus infinity, our f of x, which is equals to x all over 8 dx, when we bring, now we can say this as x dot 1 over 8. It will still give us x over 8. So let's bring our 1 over 8 outside. That will be 1 over 8. Let me repeat myself. Our question is f of x is 8. So this one will be f of, and we said to estimate the mean of a continuous random variable, it will be integral minus infinity to infinity f of x dx, and our f of x is x all over 8. Now, and I once said that our x over 8 can also imply 1 over 8 x dot 1 over 8. It will still give us x over 8. Now let's bring our 1 over 8 outside the integral. So our ranges or interval is from 0 to 4 from the question. 0 to 4, then x square. When we integrate the x, when we integrate this x will be x squared, that is x raised to power 1 plus 1. If you can remember from our secondary school mathematics how we integrate. So when you integrate this, it will be x raised to power 1 plus 1 dx, which is equal to 1 over 8 x squared. Our bound or our interval or our range is from 0 to 4. Now, which is equal to 1 over 8 into bracket. When our x is 4, which is the upper boundary, we have x squared. We integrate, and since square is here, this one will be over 2. So x squared over 2. Go and learn how to integrate. So this one will be 1 over 8 of 16 over 2 minus 0. 16 over 2 minus 0. 1 over 8 into bracket 16 over 2 minus 0. So this will be 1 over 8 of 16 over 2. So also, when we want to compute the mean, we say our mean is integral from minus infinity to plus infinity x dot f of x dx. I want to emphasize that when we are doing continuous, we use integration, and when we are doing discrete, we use summation. So here, if we bring our one said our 1 over x over 8 is the same thing as 1 over 8. So 1 over 8 integral from 0 to 4 x squared dx. When we 1 over 8, when we integrate our x squared, it will give us x 2 plus 1 over 3. X 2 plus 1 over 3. That will be 1 over 8 of x cubed over 3. Then we put our range or our interval, which is 0 to 4. That will be 1 over 8. Since 0, if you do the 1 of 0, it will give us 0. So times x, which is 4 raised to power 3 over 3. So it will be 64 over 24. 1 times 64 is 64. 8 times 3 is 24. Then we compute the variance. The variance is e of x squared. When we are doing the discrete is summation. When we are doing continuous is integration, but it still follow the same procedure. The difference is just sum and integration. So e of x squared is equal to integral 0 to 4, which is our bound, x squared dot f of x. If we bring our 1 over 8 outside, it will be x cubed dx. So if we integrate our x cubed, it will give us 1 over 8 x raised to power 4 over 4, which our bound is from 0 to 4. So it will be 1 over 8 times 256 over 4, which is 1 over 8 times 64, which is equals to 8. Then we can, after we've gotten our e of x, we've gotten our e of x squared, then we can estimate our variance, which is sigma squared equals e of x squared minus e of x all squared. So our sigma squared is 8, which is our e of x squared, minus e of x, which is 8 over 3, then everything all squared. So our sigma square is 8 minus 8 square is 64, 3 square is 9 over 8 minus 64 over 9. Sigma square is 72 over 9 minus 64 over 9. If you expand this, turn this one to 8 over 1. So 8 over 1 minus 64, 64 over 9. So this one will be, our sigma square will be 8 over 9. Our sigma square will be 8 over 9. Thank you for listening.